Hello and welcome back. This is the 4.3 video notes for the extra examples. So please title this section 4.3 Extras. We're going to do a few examples together as a group, some a little bit more complicated, still using the third term factoring. So as we've done in the past, so the 4.3 video looked like this and had the method of first step to arrange the trinomial in descending order. Second step to list the factor pairs of the third term coefficient. Third step was to circle the pair in which adds to the second term coefficient. Fourth is to replace that term with a factored pair. 5 is to write the factored form. And 6 is to use FOIL to check your answer. Now this is the method that we went over in the video notes 4.3 on third term factoring. And so we're going to do some extra examples that are perhaps a little bit more advanced, would be a good word for it. So let's go ahead and do our first example. So in our first example, let's go and have the polynomial of x squared plus 2n plus 1. And we're going to try and factor this. So in this case, I'm going to take a look at my third term, because this is in descending order, and my third term is 1. The only way to get to 1 is 1 times 1, and 1 plus 1 is in fact the second term. So I can break this apart then and make this write as x squared plus n plus 1. Because if I was to combine the terms n plus n, I would go back and get n squared. So that's always a nice check. Now when I take a look at this, I can indicate my factored form. And it's going to be, I guess I don't know why I have n's. Let me take a look at this, and where I have the n, I should be placing an x. So I apologize, it looks like I am copying off an old note sheet. So let's make that quick change. And where you see the n, these all should be x's. So I'll put them in blue. There we go, there's an x. And similarly to this situation right here, those should be x and x. There we go. So now that we've organized that, we're going to put these into the factored form. I'm going to make my binomials and they multiply by each other. And I'm going to take and put the factored pairs in here. These are both plus 1. And I can check this to make sure if I was to FOIL that this would come back out to be the numbers, the actual polynomial is what I'm looking for. So if I multiply x times x, I do in fact get x squared. If I multiply x times 1, I do get x. Similarly, the inside terms is also the 1 times x, so that's good. And the outside 1 times 1 in fact gives me 1. So I know that this is the correct answer. And then if I go ahead and do this, I'm going to box in. That looks pretty good. The answer, and I'll maybe make that binomial come in just a hair for me. Okay, so we have the binomial x plus 1 times the binomial of x plus 1. This is another way of also writing out x plus 1 squared. So this also would be a correct answer for this type of factored form. Because again, you can have two sets of x plus 1, and we can simplify that using the exponential format of the quantity of x plus 1 squared. So there's our first example on this. So let's maybe label this as example number 1 on this extra sheet. So there we go. And if we take a look at example number 2, we can indicate a situation such that, and I will use the variable of n, so n squared minus 5n minus 24. And so I'm going to make that factor tree of 24. And it's a negative 24 as I indicate that sign in front. So when I do that, I'm going to indicate 1 times 24 and 2 times 12, 3 times 8, and 4 times 6. Now I know that this needs to be multiplied to be 24, and it needs to be added to this negative 5. So in order for me to add to a negative 5, I know that my larger number needs to be negative. So I'm going to indicate that in blue so that we can identify that these numbers are negative. Excellent. So when I put those together, the ones that are going to add to give me the negative 5, in fact, show that if I take negative 8 and a positive 3, those are the ones that are going to give me the sum of negative 5. So if I break those out, I know I can work with a positive 3n and a negative 8n. And I can drop down the first term of n squared and add the plus sign, and this third term of negative 24. So that's exactly what I wanted to see. So now I've broken this polynomial into 4 parts. Again, if I was to combine like terms, I could combine this term of 3n and the term of, oh, look at that. That should be a negative 8, so let's make that a negative. If I combine those terms, then I indicate that I would get back to the negative 5n. So they are, in fact, equivalent versions. Okay, so when I take a look at this, again, I want to make that a negative 8. And I'm going to put this now into binomial form. So in doing so, I'm going to have 2 binomials. The first letter is going to be n in each section of the binomial. And I'm going to have the first one say plus 3 and the next one say minus 8. Now checking using my FOIL method, I can indicate that n times n in fact is n squared. N times negative 8 is that negative 8. And 3 times n is going to give me the 3n. And 3 times negative 8, in fact, is going to give me the negative 24. So I've checked using FOIL, and I have this process organized. So there is the second example, and this is pretty similar to those that we did in the previous video. Now, a couple more that are more advanced is what happens when we maybe have some variables that aren't just one variable, but are in 2 variables. Now, let's do that as our first example. Before I do anything, I'm going to box in my answer just to indicate that I have found my solution. Excellent. All right, so in this example for 3, we're going to have a situation where we have 2 variables. So in this equation, I have a squared plus 5ab plus 6b squared. So if I take a look at this, I'm going to, and actually I'm going to move this so I have a little bit more room. So the process for this is still the same third term factoring method. And I know that because I have an invisible 1 in my leading coefficient. And this is in descending order because we work on descending based on the alphabet. So this is a squared, and even though that's a b squared, a comes before b in the alphabet. So that's how I know that this is in the correct form. And because it has that leading coefficient of the invisible 1, then I know that I can use this third term factoring method. And it's very similar to what we've been doing previously. So I take this third term coefficient of positive 6 and I identify what my factor tree will be. So that's 1 times 6 and 2 times 3. Let's maybe clear up that 6 to look a little neater. Alright, so if I have 1 times 6 and 2 times 3, I'm looking to find the one that adds to a positive 5. And in fact, 2 and positive 3 are going to add to that 5. So this is going to then be 2ab plus 3ab. And again, the idea is to break this up so that I can identify, using combining like terms, when I combine these two terms together, I'll in fact get my 5ab back. So then I'm going to drop down the a squared and the 6b squared. So let's do that now. And when I do this factoring, the only difference when I go about this next step is I'm going to make my binomials, and I'm going to put a in the first position of each binomial, and that's exactly the same as we've been doing it. The only challenge that we have not been doing is now we have a variable of b. So I'm going to put that in the second position of each binomial. And from there, I'm going to place the 2 and the 3. Both of them are positive, so I'm going to say plus 2b and plus 3b. Now, this is going to check out. So when we check this out, we're going to use FOIL. And it's always good to check. So I'm going to say a times a, and yes, in fact, it is a squared. A times 3b gives me 3ab. 2b times a is going to give me 2ab. And 2b times 3b, in fact, does give me 6b squared. So I have then checked, and this is my, apologize for that, and this is my binomial. So a plus 2b multiplied by the next binomial of a plus 3b. Thanks for tuning in, and we'll continue with this momentarily. So example number 4 we're going to use has x squared minus 5xy minus 50y squared. Now when I take a look at this, I notice that I again have two variables. I have x and y as variable in this polynomial, and again it's alphabetical. So x comes before y, so it in fact is in descending order. And I'm really lucky because I can use this as a situation with the third term factoring because it has a coefficient of 1 here on that first term. So that first term has that invisible coefficient of 1, so I know I can use third term factoring. And so we're going to go ahead and start with our factor tree. So I'm going to take a look at our third term itself, which is this term right here. And the coefficient of that term is negative 50. So next step is to write a factor tree of negative 50. And I get 1 times 50, 2 times 25, and 5 times 10. Whoops. Knowing that I need to have 1 be negative and 1 be positive, I have the middle term of negative 5xy. And so it needs, these numbers need to add to a negative, so that means that my larger number on this column here, those have to be negatives. that really helps me indicate this, and so when I know I can place those negatives there, it's really easy for me to decide which situation works best. So in fact, it is going to be the 5 plus the negative 10 in order to make that coefficient work. So we're going to now break this up, and I am going to write 5xy minus 10xy and drop down the negative 50y squared and the x squared. So I've broken this up, so again this is the opposite of simplification. So we've made it a little bit more complex so that we can put this into the factored form. So I'm going to write two binomials, and in the first position I'm going to have an x in each position. In the second position of each binomial I'm going to place a y. And now I'm going to utilize the factor tree, and we found 5 and negative 10 to be the factor pair that we want to use. So in the binomial, I'm going to write negative 5 or plus 5 and negative 10. So to work with this check, I'm going to use FOIL. So x times x is in fact x squared, and x times negative 10y is negative 10xy. The next step is to multiply 5y times x, and I get that, and 5y times negative 10y. So that gives me, in fact, the negative 50y squared that I'm looking for. So it does check out. That's great news. I'd like you to try this one on your own. So there's only one try on your own in this video. And come to class prepared with these notes and any questions you may have. So for the try on your own, the problem I'm asking you, the polynomial specifically I'm asking you to work with, is x squared plus 2xy minus 8y squared. And I'd like you to create a factor tree of negative 8 and identify which factor pair can be broken up to add to 2xy. So go ahead and work on this polynomial. Start with that factor tree and identify the factor pair. Thank you very much.